Hello everyone, welcome to KK Mathematics, the solution to your mathematics. Today we'll be dealing with the range of a function. When talking about a range of a function, it's important to know what it means. The range of a function is a set of values of the dependent variable y that can result from the substitution for the independent variable x, and it can also be defined as a set of values of the dependent variable y, which makes the independent variable x defined. Now, to find the range of a function, the first thing for us to do is to ensure that we make x the subject. X is referred as the domain. So it's important for us to find x and make x the subject in order for us to find the range. The second step is for us to find the value of x in terms of y. The value of x in terms of y. And then the third step is for us to analyze the function just like it's done in finding the domain of the function. So we analyze the function as we do for the domain of the function. That is to say that the function f of y should approach, it shouldn't be equal to having a fraction or rational function where our denominator equals 0 for where a is any real number. So I was just to ensure that our denominator is not 0, because if the denominator is 0, then it means that that function does not exist. It means it's undefined. Well, it also means is that in graphing the function in graphing it will not exist at that particular point where the denominator of the function becomes 0. So even if you punch this on your calculator, you notice that your response will be error, marked error. That's because your denominator is 0. There is nothing like having a denominator to be 0. And the second important thing here is that the g of y, which is talking about the range, I have to ensure that your range, you shouldn't get the square root of a negative number. The square root of a negative number makes a function not to exist. So these are the criteria we use in finding the range of a function, just as we did for finding the domain of a function. And then the fourth point is to conclude on your answer. So this line, the conclusion is done in terms of y. Y indicates the range. Example here. State the range of the following functions. By given a, f of x, mapping to 1 minus 2x, and then b, g of x, mapping to x squared plus 1. Solution here. So from a, we know our a, so we can rewrite this as our function f of x being equal to 1 minus 2x. So let f of x be equal to y. So we rewrite it, so we have y be equal to 1 minus 2x. So the next step for us is to make x the subject. So we make x the subject, and in making x the subject, this is a trivial thing here. So we'll have 2x to be equal to 1 minus y, and so in making x the subject, we divide the left hand side and the left hand side and the right hand side by x. So by so doing, we have our x to be equal to 1 minus y divided by 2. And then it's important for us to note here, so from what we've done here, we have to conclude. So we notice that the function, any value of y substituted into this expression makes the function to exist. If you recall the criteria that we mentioned earlier on, we noticed that this answer that we have here, the answer we have here meets all the criteria there is, and this answer ensures and tells us that the function will exist everywhere when graphing it. And so we conclude by saying the range is y is such that y is an element of R. That is to say that every value of the real number, a set of real number, the function exists everywhere in terms of every set of real number. Let's consider the b here. So with the b, g of x be equal to x squared plus 1. So the next step for us is obviously make what g of x y. And by so doing, we have our expression to this. And so the next step is to what? Find x. Make x a subject. So making x a subject, the first thing to do is to allow x squared to stand all alone, and then we go ahead to find x. So since we have square here, we'll have to square root. So taking the square root to the right hand side, that will be plus or minus. So we have our x to be equal to plus or minus square root of y minus 1. Yeah, which is this. So with this, the next step for us is we need to find a range of this function. And in finding the range of the function, we have to analyze it. So with this function that we have here, if we were to substitute any other value there is, you notice that, remember, with the criteria that stated earlier on, that is, the function shouldn't map to the square root of a negative number. So we are going to use that criteria, and so that criteria gives us and tells us the value, tells us whether the function does not exist or exists. So with that criteria, which tells us the function does not exist at that particular point, we use that in here. So we have x to be equal to square root of y minus 1. So if we were to substitute any number which is below 1, because you notice here that if we try y being equal to 0, we'll then have the square root of 0 minus 1, which is square root of negative 1. And this, according to the criteria, that indicates the function does not exist. This falls within that. So that tells us that y equal to 0 is also one of the points where the function will not exist. So if we try y equal to minus 1 or any negative number, then we are certain to get the square root of a negative number, which indicate that the function does not exist there. If we try y equals to 0.5, still, we notice that the function does not exist right there. But any number greater than or equal to 1 makes the function exist. So therefore, we then conclude that the range is a set of y can be found, or the function will exist everywhere in a real number except when y is less than 1. So this becomes our range of the function here. So this conclusion means that this function exists everywhere in real number except when the function is, or the value of the real number is less than 1. That's where it will not exist. Okay, so this brings us to the end of today's lesson. This is KK Mathematics, the solution to your mathematics. Bye for now.